Hello my dear students, this is Physics Balaji. Today we are discussing errors done by students in JEE Mains Grand Test C7. In this question, a projectile is fired with a velocity v at an angle theta with the horizontal. It was the projectile projected with a velocity v making an angle theta with horizontal. The question was, find the radius of curvature at highest point. At this highest point, we are asked to find radius of curvature. At the highest point, vertical velocity will be 0. Horizontal velocity will be v cos theta. For this tangent, if you draw a perpendicular, that will be the radius and this will be the center of curvature. Now acceleration in this direction will be nothing but g. So this acceleration is nothing but called acceleration towards center, hence it is called radial acceleration. That means the radial acceleration will be equal to g. Radial acceleration formula v square by r. At this point, velocity will be v cos theta. In place of v, keep v cos theta square. From this you can find radius of curvature. In the next question, this question belongs to one-dimensional elastic collisions. Here a particle of mass m moves towards a smooth vertical wall with a speed u and collides elastically with the wall, and wall also moving with a speed 2u. Here particle mass m, velocity was u. Wall mass is m2, its velocity 2u, but they told it is towards the particle. That means opposite direction of velocity, hence I kept minus here, minus 2u. Assuming that the wall is extremely massive, m2 is much greater than m1. Here m2 is much greater than m1. The question was, magnitude of impulse delivered to the particle. Impulse delivered to the particle equal to impulse formula change in linear momentum. Final momentum minus initial momentum. Impulse formula, final momentum minus initial momentum. We know initial velocity of the particle is u, mass m. We have to find final velocity of first particle. Final velocity of first particle after collision, how to find? For one-dimensional elastic collision, v1 formula is this one, m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. They mentioned mass of the particle is very small when compared to mass of the wall. So mass of the particle is neglected, 0. When compared to mass of the wall, particle mass is neglected. So then m2 m2 cancel, minus u will get. m2 m2 cancel, 2 2s are minus 4u you will get. So v1 value we got minus 5u. Substitute v1 here and you can find impulse. That only this one. v1 value minus 5u, initial velocity u. Simplify this one, you will get minus 6mu. We are asked to find magnitude of impulse on first particle. So 6mu is the answer. This question belongs to Stokes' law. A spherical drop of radius r and density n is falling in air with a terminal velocity. So when a spherical drop is falling, so the gravitation force always acts vertically downwards. Buoyancy force due to medium is always upwards. As the drop is coming down with a velocity vt, viscous force will be opposing that one upwards. Terminal velocity formula 2 by 9 eta r square g rho minus rho medium. Rho m is density of medium. Here density of medium is given as n naught. And the density of the drop is given as n. And eta is the coefficient of viscosity given as mu here. Substitute these values, so you will get terminal velocity. But we are asked to find power developed by gravity. Power formula F dot V. If you open Fv cos theta. Sir, power due to gravitational force they are asked here. So F should be gravitational force, V is the terminal velocity. Here gravitational force downwards, velocity also downwards. You can see in the diagram. Gravity downwards, velocity downwards. So both are same direction. So power formula, gravitation force mg terminal velocity formula cos 0 1. Mass can be written as density into volume. Substitute to find power value. Let's go to next question. This question belongs to SHM. Here a particle moves according to the equation x equal to a cos pi t by 2. Compare this equation with SHM equation x equal to a cos omega t. Omega value will get pi by 2. From this you can find time period 2 pi by omega as 4 seconds. In SHM, when a particle moves to and fro motion, so the total time period is given 4 seconds. That means from mean to extreme, time taken is 1 second. Extreme to mean, again 1 more second. Mean to extreme, it will take 1 more second. That means from here to here, totally 3 seconds completed. In the time interval, distance traveled will be a plus a plus a. So it will be 3a. They are asked to find in the time interval of 3 seconds, what is the distance covered. Let's go to next question. This question belongs to waves. A heavy but uniform rope of length L is suspended from the ceiling. So it was the rope of length L suspended from the ceiling. A particle is dropped from the ceiling at the instant when the bottom end is given a transverse wave pulse. From the top we released a particle. At the same instant, simultaneously, a wave pulse is created at the bottom. So it is moving up and the particle is coming down. So now the question was, at what height they will meet each other? Let us assume that at x distance they will meet. At x distance, the velocity of the wave will be root of gx. V is the velocity of the wave pulse, x is the distance from the bottom. So we know that the acceleration formula dv by dt. Substitute v value here and differentiate. Root g outside, root x derivative 1 by 2 root x, again x derivative dx by dt. Rate of displacement is velocity. Velocity value we know root gx. Now root x cancel. Root g into root g by 2 you will get. With this acceleration, this wave pulse is moving upwards. Now let us find distance traveled by the wave pulse. Distance traveled by wave pulse is x. Initial velocity here, x value will be 0. Velocity of the wave will be 0. Half acceleration will be g by 2 t square. Equation 1. For freely falling body, for this another particle, initial velocity 0, acceleration will be g. Distance traveled from here to here will be total L, this is x, this part will be L minus x. So apply s equal ut plus half t square for freely falling body and we'll get one more equation. Now do 1 plus 2 to find t value. That t value substitute here to find x value. You'll get x value was L by 3. That means the particle and the wave pulse meet at a height of L by 3 from the bottom. Next question. This question belongs to electromagnetism. Two very long current carrying wires AB carrying current I0 along z-axis. Here two currents are there. Current is passing along z-axis out of the board at minus a comma 0 and a comma 0. That means, so this is origin. This will be a and even this distance also will be a. Here current is out of the board. Along y-axis, at 0 comma a, they are asked to find magnetic field. 0 comma a means here this is 0 comma a. At this point, we are asked to find magnetic field. And according to right hand thumb rule, when thumb is the current direction, then 4 fingers magnetic field will be anti-clockwise like this. Once again, when thumb is the current direction out of the board, then the 4 curved fingers represents direction of rotation of magnetic field. Draw a tangent here to find magnetic field at point 0 comma a. Here you can see it is a, this is also a. This will be 45 in this triangle. Vertical and horizontal. So if it is 45, this also will be 45. So for this circular path, it is a radius, it is a tangent. So this also will be 90. If it is 45, this also will be 45. Resolve this b into two components, b cos 45, b sin 45. Due to infinite long wire, magnetic field at distance d will be mu naught I by 2 pi d. We know this d value is nothing but root 2a. Now, due to one current carrying infinite long wire, we found magnetic field. Similarly, due to next one, Here also current will be out of the board. According to right hand thumb rule, if thumb represents current out of the board, then the 4 curved fingers represents direction of magnetic field. At this point, if you draw a tangent, it is the direction of magnetic field. Same situation here also A, it is also A. This will be 45. Radius tangent perpendicular, this also will be 45. This is B, this will be B cos 45 and this will be B sin 45. This B sin 45 and this B cos 45 gets cancelled. So along x-axis, you will be having B cos 45 plus B sin 45. That is the net magnetic field. It will be along x-axis. So cos 45 value 1 by root 2. Sin 45 also 1 by root 2. If you simplify, you will get root 2b. B value already we found mu naught I by 2 pi root 2a. Simplify, you will get net magnetic field. Let's go to next question. This question belongs to LCR series AC circuit. Here inductor is there, capacitor is there, resistor is there. Voltage across inductor given 300 volts. Voltage across capacitor is given 300. Voltage across the resistor we are asked to find. Total RMS voltage of AC is given 220 volts. VRMS formula root of VL minus VC whole square plus VR square. VL value 300, VC value 300, VR we can find. As L, C or all are in series, current will be same. That means current through ammeter is equal to current through resistor. So voltage of resistor formula current into R. We know R value given as 100. So RMS voltage is 220. You can find RMS current. This current through resistor is nothing but current through ammeter. That is ammeter reading. Now let's go to next question again. This question belongs to Faraday's law in electromagnetic induction. Here, an equilateral triangular loop having a resistance R. Here total triangular loop resistance is given capital R and each side length is given small l. It is kept in a magnetic field, variable magnetic field, dB by dt is 1 Tesla per second. They are asked to find induced current in the loop is. According to Faraday's law, induced EMF equal to minus d phi by dt. Flux formula B dot A. Here area means triangle area, so that is root 3 by 4 L square equilateral triangle into dB by dt. This is given as 1. You can find E value here. In this closed loop, I want current total EMF by total resistance. Substitute E value here to find total current in the triangular loop. Let us go to next question. This question belongs to Ginor diode acts as voltage regulator in semiconductor device topic. Here, Ginor breakdown voltage is given 5 volts. VZ value given 5 volts. And input voltage is varying from 11 volts to 15 volts. That means maximum input voltage is 15 volts. We are asked to find maximum Ginor current. Okay. Now, input voltage is variable. These two are parallel. Here VZ equal to Vout equal to ILRL. VZ value 5 volts given. IL we have to find load resistance 5 kilo ohms. From this you can find IL value load current 1 milliamp. Again in this closed loop, input voltage equal to IRS plus VZ. Another point, the total current I splits into two parts, IZ and IL. To have maximum current in Ginor diode, here this current also should be maximum. To have this current maximum, input voltage also should be maximum. That means it is a variable input voltage. In that I have to take maximum value to get maximum current. That will leads to maximum Ginor current. Okay. We know maximum input voltage 15 volts equal to maximum current is IZ plus IL. IZ plus IL value substitute here 1 milliamp into RS value, series resistance value plus VZ 5 volts. From this you can find maximum Ginor current. From this you can find maximum Ginor current. Now let us go to next question. This question belongs to YDS experiment in wave optics. Here in this question they mentioned two coherent sources S1, S2, each intensity I0 arranged like this. At central maximum, they are asked at maximum intensity how much? At central maximum, the maximum intensity we know it is 4I0. Similarly, if these two coherent sources are incoherent, then what happens to intensity they asked? For incoherent sources, intensity will be I0 plus I0 will be 2I0. Now they are asking the ratio of intensity between the two cases. For the coherent sources case, intensity is 4I0. For incoherent sources case, intensity will be 2I0. This ratio becomes 2:1. Now let's go to next question. This question belongs to vertical circular motion. Here a pendulum length is given 1 meter. Length of the pendulum L, that is given 1 meter here. It is projected with a velocity root 35 meter per second. Its horizontal velocity was V0, let us assume. After rotating by an angle theta, first of all let us find velocity here. In circular motion, if you are asked to find velocity, best method is law of conservation of energy. Energy at A equal to energy at B. Energy at A means potential energy plus kinetic energy. Similarly at B, potential energy plus kinetic energy. If you take it is the reference level, then at A potential energy will be 0, kinetic energy will be half m velocity square. At B, potential energy formula will be mgh plus kinetic energy formula half m v square. Now from this, m will get cancelled, multiply with 2, then 2 also will get cancelled. You can find v value like this. To find h, you can see it's the right angle triangle. It is L. This will be L cos theta. The total pendulum length is L we know here. L minus L cos theta will give h. So h value you can substitute here to find v value. But they are not asked to find v. They are asked to find tension in the string at this instant. They are given V0 value as root 35 meter per second, angle given 60, length of the pendulum 1 meter. Now we got V value 5 meter per second. At point B, if you draw free body diagram, the weight of the body always acts downwards. It was a tension T. If we resolve mg, this becomes mg cos theta and this will be mg sin theta. In non-inertial frame, we have to consider real force and extra one pseudo force. Here the pseudo force is nothing but centrifugal force. Now balance it, equilibrium. T balanced with mg cos theta plus centrifugal force. Centrifugal force formula mv square by L. T balanced with mg cos theta plus mv square by L. Substitute here mass given, g value we know, so theta was 60 given, so mass 1, v square value 5 square, L value 1, to find tension as 30 newtons. So given information is T equal to 6k newtons, from that we can find k value 5. Let's go to next question. This question belongs to current electricity. Here a circuit is given like this. An ideal voltmeter reading is given E by 2. Now remember carefully, ideal voltmeter means resistance of voltmeter is infinity. That means through this voltmeter no current flows. That means from this battery current will be always passing like this. There will be no current passes through this voltmeter. Let us apply this one now. In this closed loop, total current equal to total EMF. Positive connected to negative. These two cells are in series. So E plus E, 2E. By total resistance, 2 plus 1 plus R. 2 plus 1 plus R. We got I value in terms of small r. Across this cell, terminal voltage is nothing but this voltmeter reading. Terminal voltage formula for discharging cell E minus IR. The cell EMF is E. Current I, internal resistance small r. It is given terminal voltage means voltmeter reading E by 2. I value we got here, substitute here. Now from this you can find small r value. We got smaller value as 1 ohm. Let's go to the next question. In this question, they had given equilateral prism and a ray's grazing incidence given, and again it is grazing emergence given. That means here this is angle 90 and this will be the critical angle, and this also will be 90 and this will be critical angle. We know that R1 plus R2 equal to A. Here R1 value see here, R2 also see, substitute here, 2C equal to A. From this you can find critical angle value 30 degrees. We know critical angle condition mu equal to 1 by sin C. We know C value 30. You can find mu value refractive index of prism. We are asked to find refractive index of prism.
Thank you.